My name is Mike Crater. I am the district sales manager for the Midwest group for Rhino Carbon Fiber. Just a couple of general housekeeping things here as we go through this presentation. You guys will all be on mute for the duration of this, but there is a chat bar that you can take a look at down there at the bottom of your kind of option screens there. You're welcome to type out a question at any point in time. I'll keep that open as far as answering any questions as we go. But if you would like, you're more than welcome to basically just kind of hang on until we get to the end. I'll open it up to make sure that everybody has adequate time to answer and get answers to any questions that they may have. So today we're going to cover quite a bit of information. It's going to go through kind of back history of Rhino, kind of why foundation walls fail, some of the other options that are out on the market, and how carbon fiber differs from that. And then we'll go through the actual installation process, some tips and tricks, some opportunities for upsells, and some adaptations to the system itself. So like I said, any questions, feel free to write them out, and we'll cover them at the end, or we can just unmic everybody, and we'll just kind of do a Q&A towards the end. So Rhino Carbon Fiber was developed by Luke. Some of you on this call may know Luke or may have met him. Basically, he was the owner of a company called The Basement Guys here in Central Ohio. I ran that for him for about 7 years. So the reason we tell you guys this is essentially we feel that it's important that you guys know where we came from. It kind of explains how we got to where we are today. You know, obviously being a large company that we were, we used a variety of different products on the market and weren't satisfied with what was currently being offered. So that's where Rhino came from. That's why we have the kits that we have, is basically to help you guys control your inventory, procedures as far as installation goes, and eliminate as much loss as possible. So the Basement Guys was founded in 2000. In 2001, it was an early adopter of carbon fiber. We were actually using a different product at the time, and then by 2003, the shortcomings of other products were excessive enough that Rhino Carbon Fiber was developed. Patented system was developed specifically for the application that we're discussing today, the bowed walls. We currently hold patents on that system in both the United States and Canada, and we have other products that are patented or patent pending worldwide at this point in time. We do have a Canadian partner, a parent company, AGT Products. Their brands include Rhino, Dry Core Barricade, and Insul Armor. So if you guys ever see the subfloor panel that you would put down in a basement or a concrete slab prior to installing any flooring, that's the company behind that. Just a really, really brief back history on carbon fiber itself. It was actually kind of discovered by accident when Edison was trying to develop the light bulb. That's when the filaments were discovered at that point. He basically joked and said that it makes a terrible light bulb, but it's incredibly strong. So fast forward a little bit, in the 50s, the tensile strength was kind of further developed, kind of manipulated to become even stronger than it originally was. And in the 80s is when it really kind of became prevalent as far as your aerospace and military applications, because of the strength and the weight of the material was very low. And then by the late 80s and 90s, it had universities and other entities were researching it even further and basically developed it into what it is today. Super lightweight, high strength, extremely high tensile strength material that's used through all different types of industries. So when looking at a foundation wall, there's typically 4 stages of damage. You're going to have your soil expansion, and your cracks are going to develop at that point. That progresses into inward movement and varying degrees of severity. As that continues, you'll typically end up with wall shearing. What that is when the wall basically slips off of the bottom block that's held in place by the concrete. And ultimately, if this is left unrepaired, you're going to end up with a wall replacement. So we'll go with kind of through the different stages here. This is going to be your typical foundation wall. It could be block or poured concrete for the road wall application. It's universal. It does not matter which one you're working with. So you've got your backfill here. Traditionally, it's going to be backfilled with stone, but a lot of times that doesn't happen. A lot of times it just gets backfilled with the dirt that was excavated on site. You end up with water that's naturally going to drain to that area. Poor downspouts, poor negative grade at the foundation wall there is going to cause excess water, and that is 90% of the problem when it comes to a road wall, that or the wall being totally unreinforced. Over time, as this water sits here, it gets in the soil. In parts of the country where you have seasonal changes, you're going to end up with freeze and thaw cycles that are going to basically cause this water to expand in the soil, and it's going to push it over time. That's going to be called your outside pressure. As that continues, you're going to end up with cracking either in the blocks, mainly in the joints. For road wall, you tend to kind of see a horizontal joint that'll fail just below the surface there. That'll kind of be what we call the hinge point of that wall. It could typically be the location with the most amount of deflection and pressure on that wall. So you got stage 1 here, the cracks develop. Stage 2, you actually have cracks that are opening up. You'll sometimes see stair-step cracks develop in the corners. At this point, the wall has started to move inward. That continues over time, and again, if unchecked, this is what the shear looks like. Basically, this wall just kind of slides off of this block. This block can't go anywhere because it has dirt and then concrete on the other side, so it's kind of held in place, but you'll end up with a wall that kind of slips off of there. And then this is stage 4. Some of you have probably seen this or been a part of it. It's not a particularly fun thing to do. Another method would be a wall push. Sometimes that's done in lieu of a total wall replacement, but you know, if there's enough block damage and joint damage, ultimately the only option would be a total wall replacement. So for fixing a bowed wall, there's quite a few different products that are on the market. We're going to go through them, some of the shortcomings of them, and some of them you can even use carbon fiber to help address some of those things that may be considered shortcomings of some of these products. So you're taking your typical bowed wall, it's starting to move. You know, you've had that pressure there for a couple of years, and the first one that is a very common one is going to be a tieback. So they're fairly expensive. You know, it tends to damage the block that is right around the anchor plate, just because there's enough pressure there trying to counter the forces that are being pushed on the wall itself. A lot of times excavation is required on the outside to be able to anchor that out. There are some systems where you basically just kind of push the rod out into the yard and then you have a plate that anchors out in the yard. Those are less invasive, but some of these systems that are out there require, you know, almost like concrete pilings or pads. Some of the issues for homeowners would be the aesthetics of the plates themselves. They're pretty noticeable. And then, you know, to say that you can't finish the basement, that's a little much. But if you do install a finished basement after tiebacks have been there, you have to basically install access panels so you can continually keep the tension on the rods themselves. So these are kind of what your typical anchors would look like. You know, they're going to be anchored out into the yard. You're going to have your rods that go to the wall, and then you have a corresponding plate on the inside of there. So these would be what you'd have to leave access panels for if a customer was planning on installing a basement finishing system after that. So the problem areas would be you're not really truly supporting the wall in the other areas. So what this can lead to is either damage in this area, or this part of the wall can basically push if this pressure still exists, which most of the time it does, because a lot of times there's nothing being done to address the root cause of the pressures on the wall itself. So yeah, like we discussed, you've got excavation that's typically necessary, not guaranteed. And then you have shearing that can develop here or here because this is unreinforced. Now, some of our contractors that do install wall anchors, or when wall anchors are called for, they'll use a strip of carbon fiber to span from the top to the plate, and then from the bottom of the plate to the bottom of the wall. What this does is it kind of helps tie everything together and helps redistribute that pressure. So this pressure that's continuing to remain is basically countered by the tensile strength of the carbon fiber. Some guys will even go as far as to create whalers of sorts with carbon fiber between these locations just to increase the load capacity of the wall itself. So that's something to kind of keep in mind if you guys do install wall anchors or they're called for. Just be mindful that you can use multiple products to create a better repair. This kind of explains the real drawback of some of the anchor systems that are out there. Not saying that all of them cause this type of damage, but it is a possibility if installed incorrectly. So this is kind of a bird's eye view of the top of the wall looking down into it. So these would be the hollows of your block. So you have your rod that comes through your tie back plate, and as you basically install that and you create the force to get that tight and to keep the tension on this system to keep the wall from bowing inward, you basically have your inside force, your outside pressure, and over time you can develop cracks in the block itself, and that would essentially lead to crushed blocks or damage between the actual plates themselves. And this was actually a job where they had done the anchors and there was still movement occurring between the anchors because of the spacing that was called for. So they used carbon fiber in this application as a secondary method of repair. This was basically to come in and increase the capacity of the wall. The next one is probably the most common because it's been around the longest. This is going to be your stationary beams or just your typical steel I-beam that's installed in the basement. Drawbacks are they're fairly expensive. I mean, there are parts of the country where you can get steel for pretty cheap, but if you're the guy that's paying for some of the beam systems that are out there, you're paying quite a bit in shipping just to get it from door to door. They're extremely obtrusive. They stick off of the wall. You're going to end up with quite a bit of lost space in a finished basement scenario. They're very, very noticeable when your customers would go to sell their property. It's almost guaranteed that it's going to get noted on an inspection, possibly even find some issues with it just because of the amount of attention that it draws. That tends to be a little bit scary for prospective buyers. And then there's just a lot of room for interpretation as far as how that process is done and done properly. There's a lot of different methods for installing steel beams. You end up with a lot of blocking in a lot of the situations. So we'll go through some of the differences here. So to start out, you're basically going to have, you're going to have to open up the floor to get the beam set on the footer itself. Typically it's going to be a 13-pound I-beam that's called for. So that's going to be about 6 inches of steel on the wall itself. And then you basically concrete that back in place. Then you have your bracing up in the floor joists there. Typically code calls for a minimum of 5 joist cavities uninterrupted for proper bracing for the top. If your joists are running parallel with the wall, you then have to basically use 6x6s and things of that nature to get those lagged in and tied in properly. So really it's extremely time consuming. You end up with a lot of lumber that has to be involved in that as well. And then one of the shortcomings of that is you tend to tweak the floor joist when you do that. So you're basically taking this load and you're putting it up into the floor joist. And you're creating a situation where there's a lot of load on just simple 2x material that's not really designed to take that kind of load. Another issue with steel I-beams is since this is a rigid, straight piece of steel, it's only really making contact with the part of the wall that's bowed the most. So that leaves you with cavities behind the beam and the wall itself. So you essentially have to backpack that with concrete. Pretty tough to get it done completely, to get it really nice solid fill in there. It's something that a lot of guys really struggle with. It is time consuming, but it's the most critical thing of a steel I-beam is to get that area filled, and unfortunately that typically does not happen. If you don't do that, what it allows is the wall to basically continue to fail to the point of to where it hits that steel I-beam. So essentially the beam has to catch the wall before it actually is in tension. That's what's called wall shearing. So your power beams are going to be pretty similar to a steel I-beam. The main difference is they like to promote the idea that you're going to be able to straighten the wall. Again, the issue with this is because of the top bracket, you're again putting a lot of pressure onto those floor joists, pretty much in excess of what that wood is capable of taking. So the opportunity for floor joists to bow or to break over time is pretty high. You have a lot of the same negatives that you do with a steel I-beam as far as the application and some of the aesthetic issues of it. Again, your beams aren't going to touch the wall. But the real thing that is kind of bothersome about this is a lot of those systems that are with this are going to be that you don't actually remove any concrete. So you're essentially relying on 2 bolts into the concrete of an unknown thickness to essentially hold that pressure at the base there. This is again going to be kind of a bird's eye view of the wall itself. You've got your beam on there, kind of similar to a wall tieback as far as what you're exerting on the block itself. Again, your outside pressures, your inside force, very similar to a tieback. It's going to create damage to the block itself. This is what they typically look like. This is a really, really poor install of one. You basically have just a 2x6 attached there, and then a piece of thread. But you can see here this threaded rod is what's supposed to essentially push that wall back. So that idea is every summer when the soil is extremely dry and potentially pushed off of the wall itself, you're supposed to be able to crank that and straighten that wall over time. The theory of it sounds really nice. The practice of it is a little bit unlikely to happen. I mean, you've got tons and tons of dirt sitting or gravel sitting on a wall. So you can kind of think back to that slide that showed the pressures that are being put on the wall itself from the outside. If you go and just tell homeowners to crank on this thing a couple times a year, it's not going to take real long before they end up damaging the block. So for a lot of people, the biggest shortcoming of this system would be the loss of space that would be there. So you're typically going to have about 6 inches of steel on the wall. You have to frame away from that. So you're going to lose about a foot off of the entire part of the basement. So essentially, if you have a 20 by 20 basement, you just lost 80 square feet of living space. For a lot of people, that's just not acceptable. They're not going to go through the added expense of finishing a basement if they're going to lose that kind of square footage. Not to mention, you're not really going to have a good feel for what's going on behind here. So the one that I kind of briefly mentioned would be a dig and push. This is actually a project that we did here in Central Ohio when the basic guys are still operational. I oversaw this project that was a residential home. It was a complete mess. The people had just bought it from a bank, and it had basically been abandoned for, I think, about 10 years or so. I believe there's like a total of 40 carbon fiber straps that went in. So the dig and push is basically a last-ditch effort to save the wall. It's extremely time consuming, it's dangerous, and it still has to be reinforced after you get the wall pushed back into place. So if you were to just push this wall and reset it, put the soil back on it, it would very quickly go back to where it was. So this isn't a fix as far as permanently repairing the wall, you have to do something to reinforce the wall, or you'll be right back where you started. So this is where the carbon fiber portion of it comes into. We're going to briefly discuss some of the other options that are on the market, just so you guys can be educated as far as where we're different to other systems that are in the market. But the benefit of carbon fiber in general, regardless of the manufacturer, is going to be no deterioration. It's going to limit the movement, or in most cases with our systems, it's going to completely stop it. It's going to be extremely minimally invasive, and it's fast and clean. So the carbon fiber typically ranges, depending upon the manufacturer, anywhere from 5 inches to some of it's 2 feet wide. It just depends upon the manufacturer. But some of the plates, there's a plate material that's on the market. It doesn't have any connections to the top or bottom. It's the epoxy is kind of difficult to get to bond to the plate, because you can't really tell if it's saturating properly. But it's going to basically come up to the top of the wall, stop, and it typically stops just below the floor. That's going to be really common for most of these systems, because we're the ones that hold the patent on the top and bottom connection. So your outside pressures are here. They're pushing. The tensile strength of the carbon fiber band is doing what it's supposed to, but due to the lack of your top and bottom connection, over time, as that pressure continues to go on, you end up with shearing, just like you do with the plates and the beams. And this is where carbon fiber, in the beginning, the infancy of it, engineers would say, well, yeah, it's going to hold the wall together, but is it really going to do anything to hold the wall in place? And the answer was no. And that was what the issue we had with the system that we were installing at the Basic guys way back in the early 2000s. So the next one is going to be your 12-inch wide strips. We use this for general crack repair purposes. We do not use it for bowed wall applications, simply because there are no connections with it. But there are some systems out there that this is what they use to reinforce a wall. It's going to be the same scenario as the plate. You have no top and bottom connections, so therefore the wall can basically shear in as one. And when you do this, you end up with a pretty bad failure. Another shortcoming of the wider strips is going to be you're encapsulating the entire face of these blocks, so they can't wick moisture like they're supposed to. So blocks are naturally porous. They're designed to channel the water. If you encapsulate the entire surface of a block, you run the chances of water being held in that block, and over time, the moisture will basically just peel or delaminate the carbon fiber. So the next one we're going to talk about is going to be the carbon Kevlar blend, the straps. I'm sure most of you on here probably know which ones we're referring to. They were the ones that originally came up with a top connection, and that was in response to the fact that they were starting to experience issues with wall shearing in. So they created a necktie at the top. The only problem is it's not really in tension. There is a way to get it in tension, but unfortunately, most of the time they're installed in a method where there is no tension that's present on that connection. They're also installed into the rim joist rather than to the sill plate, which is an acceptable method, but your opportunities for movement to occur up there due to the distance between the wall and the rim joist is much higher than going into the sill plate itself. The real shortcoming of the system was you still had no bottom connection to tie into this point below the shear point. And this is what happens when you have a wall that does not have any connection. Again, I oversaw this project. I received a call from somebody that had purchased this home several years before, hadn't really shown any signs of issues. She called late on a Friday, said, hey, I think I have a problem in my basement. I said, okay, fine. I'll have a guy come out, or as early as I can get there would be Monday morning. And she accepted that. And then about 15 minutes later, she called back and said, I don't think I explained myself really well. My basement wall is laying in my basement. And at that point, I had pulled a crew and had them get over there and take a look at it, had them send me some pictures, and this is what they walked into. So obviously a very dangerous situation. You can see here that there was a post that was basically holding up the support beam for the entire house. So this is what, this is about the worst case scenario you could ever experience as far as a carbon fiber or carbon Kevlar failure. And this is really, truly illustrates the importance of, having those top and bottom connections. So the benefit of carbon fiber, as far as your space savings, this is going to be universal for all of them. It's going to finish smooth, flat to the wall. You're not going to experience any loss of space. Typically by the time you prep your walls, the thickness of the concrete that you removed is essentially equal to the thickness of the carbon fiber. So the fiber almost ends up being flush with the block around it. So again, you have your outside pressures and everything going on, but this is where the difference with our system comes into play. So we were the first to the market and hold the patent on tying into the sill plate. So we provide brackets in each one of our bowed wall repair kits. What this does is it basically links you into the first available framing of the home. Obviously this piece of the sill plate has the entire weight of the structure sitting on it above it. And most of the time it's going to have connections down through the wall itself. So you would essentially have a piece of lumber there that has, a couple hundred tons of weight sitting on it, if not thousands, depending upon the size of the structure. So what you're doing here is when that pressure is exerted, you're eliminating the opportunity for a shear at the top of the wall. And then for the bottom, we have our carbon fiber pin. Most of you guys that are on here, you know the process. But essentially what the point of this is to get you into either the footing or into the slab itself. So as this pressure is exerted on the wall, this block can't slip because it has an anchor point below that final block that's held in place. As you saw from the previous pictures, it's obviously very important. We've been around for over 15 years at this point, and we've had 0 failures. And engineers basically spec this as a requirement now for bowed wall application. Another benefit of our system is you can paint it. We've done everything from $10 a gallon, the cheapest paint we could find at Lowe's, up to high grade like fiber lock systems that have fiber mesh in them for waterproofing, stuff like that. Everything sticks to it. We get the question sometimes as far as when to paint it, and it doesn't really matter. We have guys that'll paint when the epoxy is still tacky, or you can wait the 2 days for the total initial cure time on the epoxy. It doesn't matter, and it can even be done months later. We get the question a lot: is the sheen of the carbon fiber epoxy, is it too slick for paint to stick to it? And the answer is no. The only thing that doesn't stick to it is the base coat of dry lock. So if you use a 2-stage dry lock, the base coat or the waterproofing agent won't stick to it. Another huge benefit of carbon fiber is going to be when finishing a basement. If that's important to your clients, this is the true benefit of carbon fiber system, is you can basically finish as close to your wall as whatever the mandatory air gap is for the city that you're building. And typically going to be about 5 inches is your typical air gap. And as you can see, that results in very, very little square footage loss. We'll jump into the training portion of it. I'm assuming this is probably what most of you guys are here for. So if you haven't already figured it out, the main points of the carbon fiber is to stop inward movement. Our system has the top and bottom connections, and it is a wet lay application. It's very important that it's a wet lay application. You know that simply because when you receive the fiber, it's going to be just a woven raw fabric at that point. So it's going to conform to whatever angles you need it to, whatever surface you need it to. There are no restrictions to it. You're not going to have to get creative as far as holding it in place or getting it to conform to the wall itself. The advantages, obviously, as we've discussed already, it's patented and engineered and warranted. The warranty is 25 years for the structure itself. Any issues, we replace the material or provide additional material. There is no excavation required unless the wall is past 2 inches. We typically recommend that the wall be pushed at that point. It's extremely fast installation. I used to have crews that could do 25, 30 straps in a day. You get a couple of guys that are comfortable with it, they can knock some serious carbon fiber installations out for you. It can be used on both poured concrete and CMU, so it's very adaptable. As we discussed before, it can be utilized with other repairs and then the thin profile. This is what your typical Rhino bowed wall kit will look like. We do have a different material as far as the carbon fiber itself, but the rest of the components will remain the same. We do have a vertical weave carbon fiber that's used for slightly taller applications or applications where they're, close to the 2-inch limit as far as the wall. It has a slightly higher tensile strength. Either one of them are going to be more than adequate, and they're both going to be designed to a factor of 2. Basically, that wall is going to be twice as strong as it needs to be to counter the forces that are on it. So these are going to be real world looks. This is going to be your typical telltale wall damage that you're going to see. That's going to be your indicator for inward movement occurring. Like I mentioned, you have this joint that fails just below the soil level. That's where the wall starts to hinge. And this is a diagram for our standard design spacing. This is in every single instruction manual that we process and put out into the kits, which you'll have every one of the bowed wall kits you ever receive from us will have the instruction manual on it, and the very first thing on there is this spacing guideline. So you have your 2 inches of maximum deflection on the wall, and that's just kind of an ASTM industry standard. That anything in excess of that's just not a real great idea. It's not really a good return on investment for your homeowners, and it's just not considered anything more than a safe measure exceeding 2 inches. We can do it. We have done it, but it's typically not recommended. So what you're going to do for your bowed wall applications, you're going to start 2 feet from a corner, and then you're going to have 4 foot on center maximums. In the event that you get to something that's going to interfere with that 4 foot maximum, like a window, you basically have to close that spacing to avoid that obstacle, and then you can start your 4 foot spacing over again. So like in this situation here, their 4 foot spacing would have been on this window. Obviously, you're going to lose your ability to attach at the top. So what you would do is scoot this strap over, and then from there you would pick up your 4 foot spacing. So this is important that you just don't go out to a job and say, okay, it's a 24 foot wall, you need 6 straps. You need to look at it a little bit closer than that. It could be a window, it could be plumbing, it could be electrical that's there. It could be as simple as, there's a water line that's running on a certain part of the wall up at the sill plate, and you don't want to take the chance of moving it and breaking it if it's old copper or something like that. So you just kind of have to note those things so you're not, sending a crew out there unprepared, or you end up having to install a strap or 2 at no cost because you didn't catch it during the original inspection. So your wall prep and your joint repair is going to be the most critical point of any carbon fiber application. I kind of always say it's like painting a car. The results are only as good as your prep work. And in this application, it truly is 100% the case. So what we recommend is to grind the surface of the strap locations with a diamond cup wheel attached to a HEPA shop vac so you can confine all the dust. But what you want to achieve is a bare block to where you can see the aggregate in the block itself. And this is done even if the wall has never been painted. It could be a brand new home that's never been dirty, has zero damage and zero coatings on the wall itself. You still need to grind to get to the aggregate on the block. So typically for block applications, we recommend that you use your vertical mortar joints, your opposing vertical mortar joints, as your guidelines for what you're going to grind. That's going to be the easiest way to keep the prep area straight and kind of give a uniform appearance. If the sill plate is recessed, which it's most commonly going to be, just kind of slightly round out that top edge with your grinder when you grind that final block. You don't have to go crazy and create, you know, like a certain angle or anything like that. You just want to round that top edge out so the carbon fiber can kind of ease over that that top final block and make its way back to the sill plate. Another really, really important thing is to replace the failed joints with a hydraulic cement or a fast setting cement. If you don't replace the joints that have failed, you'll basically allow that wall to continue to hinge. So the carbon fiber is not going to allow the wall to come in any further, but it's not going to do anything if the wall tries to relax. So just like we talked about some of the stationary beams in the summertime when the soil is relaxed off of the wall, if that wall wants to retract and you have joints that were not repaired, it will be able to do that. And what you end up with is a small ripple in the carbon fiber. It's not going to create a failure. It's not going to tear, but you will get callbacks and you will get questions from your homeowner. So fill in your joints. Any joints that are kind of below or shallow, once you've done your wall prep, fill those in. You can kind of see this here. This wasn't a failed joint. This joint was just low. So rather than grinding the face of the block until that's flush, you can simply fill that in with the cement product. After it's dried, you can lightly scuff the surface again. That will give you access to those pores again. You don't want to necessarily purge this whole thing. You just want to get the joint. So lightly grinding it will kind of clean all this back up again. At this point, you're going to go ahead and drill your bottom shear pin location. You're going to keep it centered with the area that you've ground, and you're going to go about 3 inches into the concrete or the footer, whichever one you have access to. And you're going to keep that as upright as possible. Obviously, to turn a 3/4 inch mason's bit, you're going to be using a rotary hammer drill. So those are pretty large. So you're not going to be able to get it perfectly vertical. But typically, if you rest your drill right against the wall and kind of hold it in place with your hip or your leg, that'll get you as close to vertical as possible, and it'll eliminate any opportunity for that weave gun to kind of jerk around on you. So I always tell guys to use their hip. It kind of helps you hold it in place. And then obviously, after you've done all your grinding, at a minimum, you want to take a broom and brush the wall off. Typically, most guys will do all of their grinding, and then they'll come back with their shop vac and just vac the surface off before they do any carbon fiber application. So your top sill plate connection is really simple. You're going to go ahead and pre-drill your sill plate locations for the lag bolts so you don't split the sill plate. Once you've done that, you're going to wet out the top 6 inches of your carbon fiber. Go ahead and, trowel that in place with, your plastic putty knife or whatever it is you want to use to disperse your epoxy there. But yeah, get the top 6 inches laid out. Go ahead and lay the bracket into it, and you're going to roll it 2 complete times. The most important thing to pay attention to on this is to make sure that the carbon fiber is not over in either one of these holes. If they are and you go to drive your lag bolts, the lag bolts will grab the carbon fiber, essentially twist it up, and it's going to mangle that top part pretty bad to where you're probably going to have to cut it off and start over again. The other thing to look for is to make sure that your carbon fiber on the final wrap is coming down and behind the bracket here. If you were to flip this around and have the carbon fiber coming over the front side of it, this would not be in tension any longer. So it's very, very important that the carbon fiber is coming up and behind and then straight down behind the bracket itself. Once you have everything secured at the top, go ahead and drive your lags in. You're going to roll the carbon fiber up, tuck it up into the floor joist, get it out of your way, and you're going to go ahead and start to apply your base layer of epoxy. You just kind of go back and forth on a zigzag motion. You want to make sure that you have a uniform wet appearance. Couple of things that are kind of helpful tricks. Only apply the epoxy for about half of the wall, and then go ahead and trowel it out into place. This will help you from the epoxy running all over the place. When you apply it in these beads, it tends to get a little bit heavy and it wants to roll. So if you go ahead and evenly apply that, get it troweled out, it'll stay in place. And then once you have the top half of the wall done, go ahead and do the bottom half of the wall. Get that troweled out. Look for any wet spots or any dry spots, sorry. And then also something that we get a lot is guys say that we don't provide enough epoxy in the kit. There's two things to note there. One, you're not building a finished car part, so you don't need a super thick layer of epoxy on the outside. And where a lot of guys find that their epoxy is going, when you're troweling it out, it tends to build on the outside edges of the strap location. So you'll end up with like a really thick bead just outside on the edges of the carbon fiber where it's not doing anything. So kind of at this point, once you start troweling out your epoxy, kind of push all the epoxy back to the center where the strap is truly going to be installed, and that'll help a lot with your epoxy consumption. Any excess epoxy that you have at this point, you can go ahead and, if you've gotten anything on the floor or you have any left over on your trowel, go ahead and just put that into the pinhole location that you pre-drilled at the bottom. So at this point, you're going to go ahead and unroll your strap. You're going to pull it tight, and then you're going to lay it into your epoxy, working from the top down in this portion of it. This is going to allow you to make sure that you're running straight, and then you're going to, once you have your strap positioned where you want it, go ahead and cut the strap if necessary. Leave yourself 6 to 8 inches of material running out onto the floor. That's going to become your bottom anchor. Do a final check, make sure that the strap's as straight as it can be, make sure that there's no ripples in it. Check and make sure that there's absolutely nothing going on, because the next step is going to be installing your final top coat of epoxy. It's going to be the same thing as your base coat, but it's going to be a lighter coating. So your back and forth zigzag motions are going to be much wider because you're putting less material out there. And then you're going to basically the final result is you want to make sure that you have a truly wet look on the entire surface of that carbon fiber. And then the final step is going to be your bottom pin. It's not a separate component. There's no additional materials that go in there. What you do is you take that 6 to 8 inches of carbon fiber that you've left out on the floor. You're going to fold it. You're going to get it wet. Fold it into a triangle like you can see in that middle picture, and then you're going to just twist it to the left or the right, and then you're going to simply insert it into the hole that you've pre-drilled, and then top it off with epoxy to where it's flush with the top of the floor. If you don't do that, you have the opportunity for water to come up through it if it is a wet environment. So sealing it off entirely with your epoxy will kind of help dam all of that up and make it solid again to where the water can't make its way through it. We get the question a lot, how do I get my bottom pins to look like this? The only way that you can do that is if you allow time for this epoxy to kind of start to tack. So I usually will tell guys to go ahead and get like 3 or 4 straps on the wall, not to really worry about what this looks like at this point in time. Go ahead and install the pin, but don't worry about what it looks like. And then come back to it. Once the epoxy's tacked a little bit, you can kind of work the edges a little bit and feather it out. and the epoxy will be tacky enough to where it'll actually hold that fiber in place. It's not going to affect the strength of anything if it doesn't look perfect, but it does look more professional. But it's really just aesthetics at this point. As long as you have this anchored into the concrete or the slab itself or the footer, it's not going to go anywhere. This is just for professionalism. And then you're going to do your final coat. You know, obviously by doing that bottom pin, you're going to manipulate that strap a little bit. You're going to pull it off the wall a little bit, just getting that set. So this is going to be your final coat at this point after the pin is set. So some of the adaptions that you can do to the system itself, and these are just kind of footnotes to conversations that we have from people all across the country. It's going to be, you know, not really common, but it does happen where you're going to run into a home that doesn't have a sill plate. In that case, you go straight to the rim joist. That's the best case scenario. If there is no rim joist, sometimes you'll have, you know, floor joists that are toothed into the block, or it's poured concrete all the way up to the subfloor, or there's like a cold cellar that has a concrete pad that's poured directly on top of it. In that application, you're going to run a strap horizontally across the length of the wall. And what that does is it basically ties all of the straps together. So if there were to be like a point load on one location, it basically redistributes that tension across the top of the wall and basically calls on strength from all of the straps rather than one having to take the brunt of that force. Another thing we get a lot is, what do I do with existing drainage systems? So if you come to a home that already has a drainage system in there, you know, some of the systems sit far enough off of the wall to where you can still manage to get your drill bit in and drill for the bottom attachment. Obviously, you're going to have to go to the footer in that application, so make a note of that because you'll probably need to order a larger strap as far as the length goes to be able to hit that depth. In worst case scenario, if it is a system that's finished tightly to the wall, you'll have to remove a small section of the concrete, kind of move that system away from the wall, go ahead and make your bottom pin, and then put that system back. Again, very important to note, so your crew's prepared and so you can charge adequately for the additional labor that'll go into doing that. Ideally, you would install the bowed walls at the time of an interior drainage system, so that way you could install the pin directly into the footer, and then you would obviously want to have your straps installed prior to putting your waterproofing membrane on the wall and having your concrete poured back in place. But we get the question of, if I'm doing these straps at the same time as a drainage system, do I still have to pin them? The answer is yes. You know, the weight of the concrete that you're putting back isn't going to be enough to hold anything, and a lot of the times with the waterproofing membrane, they're not going to be in direct contact with the straps themselves, so still pin it. It's actually the easiest time to do the pin because you have direct access to the footing itself. So this is how to streamline the installations, and this kind of comes from my time of managing crews. The most efficient way to do this is to break the job up into certain tasks for each team member. So we would typically have one guy would go in after everything was tinted off and covered. One guy would start grinding immediately and keep going. And the other person would be pre-drilling the holes at the bottom and pre-drilling the sill plate bracket attachment. At that point, by the time he had completed that, the guy that was grinding was on strap 4 or 5 location, and the guy that was doing the sill plate and the pinhole drilling would go ahead and start installing the carbon fiber. That's the most efficient way to do it. And then at that point, once the team member that was doing the grinding finishes with the grinding, he can either start installing the straps as well, or he can go back and start manipulating the bottom pin locations to get those as clean as possible. And then he can start doing general cleanup at that point, because once the grinding is done, your plastic can come down. Obviously, still leave it on the floors, but you know, he can start getting stuff out of the basement, tools cleaned up, things of that nature. Before you leave the job, you want to check the edges of the carbon fiber for the toe to be laying flat. We want those to be really well bonded with the wall itself, not for strength purposes, but for safety purposes. If you have those little toe ends hanging up, once they cure out with the epoxy, they're going to be really thick razor blades. They're super sharp. So that's something to check for. Make sure those are laying flat. Any epoxy that's on the edges, go ahead and push that back into the strap itself, and then adjust your bottom attachments at the slab or the footing. And then we have a product, the Tough Wipes. They're basically used to clean epoxy off of anything that you get them on. So that could be your team members, your tools, the job site, anything of that nature. They're really good to have on hand just to clean those up. Some guys will even keep them and use them to clean the inside of their truck. So this is what your typical bowed wall application is going to look like. You can see your pin attachments. They have a really clean edge here. I think they actually take some of this off, which you can do as an added measure to keep your epoxy lines clean. But you can see here the sill plate's actually recessed, so they slightly ground the top and then just fan back to the sill plate there. They repaired all of their joints that were broken, so that way that wall can't hinge. And you can actually see here they had to adjust for their spacing. So they were 2 feet out the corner. 4 foot would have put them in here, so they went to the right side of the window. And this is just our crack repair material here. There was some cracks that had developed below this window that they wanted to take care of, in addition to the bowed wall. So if we had gone a little bit further over here, there'd basically be a strap right on the other side of this window too. This is an application where the wall had already sheared, which is fairly common. A lot of times people let this go longer than they should. And the engineer on this job called for bowed wall reinforcements, and then he also wanted to have this installer do a 1 foot wide crack repair at the bottom to basically grab a hold of that bottom course and the one that's directly above it where it shears. He just wanted additional tensile strength in that area to offer more strength in there. Now, if you have a wall that's sheared like 2 inches at the bottom, typically what we recommend is you would install your straps normal, but then you would knock a hole in between each strap location and put in a piece of rebar and fill that full of mortar. And what that does is that basically creates another form of defense against that shear getting any worse. So it basically gives you additional shear load capacity by doing that. So in times of severe shearing, that would be what we would recommend. We get that question quite frequently as well. So some of your additional uses for the carbon fiber, specifically the bowed wall width, would be crawl spaces. That's always a really tricky one to handle because a lot of times there aren't floors. So your beams aren't going to be a possibility. Plus, nobody really wants to drag a I-beam, army crawl an I-beam into a crawl space. So it's much easier to get a carbon fiber in there. You're almost always going to have access to a sill plate, and a lot of the times it's the footer. If they didn't pour a concrete cap in there, you're going to have direct access to the footer. So it's a great application for crawl spaces. Obviously, we've been a part of quite a few commercial applications, so it's not just limited to residential foundation walls. And then a lot of guys will do this at the time of egress window installs. And the point of that is you're obviously removing a large portion of the strength of this wall by putting that window in. So they'll install the carbon fiber there just to prevent any future damages that could be caused because of that opening. It could be used as a lintel, again, crawl space openings, any type of opening in a wall that exists, the carbon fiber can be used to reinforce it. Again, these are just a couple of our other products that we have. We have some stitch kits for poured concrete, our crack repairs that can be used to supplement some of the other damages that are done during a bowed wall application. It's pretty common. Our installers will install a crack repair kit directly on that joint that failed the length of the wall, and they'll do that just to get a higher tensile strength in that area to keep that wall from being able to hinge right there. And then we have corner repair kits as well. So if you're doing a bowed wall application, you have an inside corner that's starting to separate. you can use the corner repair kit to kind of tie that all back together. So your competitive selling aspects of the carbon fiber system that you can really hit on, it's going to be the least invasive way to address a deflecting wall. Our system in particular is going to be engineered and warranted. You have complete contact with that wall, the entire length of that wall. So kind of a takeaway from the previous slides that we looked at, just about everything else on the market doesn't support the entire wall, top to bottom. Carbon fiber does. They're not going to lose any space in their structure, and they don't have any continued maintenance. So they don't have to go down and tighten things. They don't have to go down and keep an eye on, you know, what's my soil level look like as far as, is it off the wall? Can I tighten this thing? The carbon fiber is you know, pretty much you install it and you don't have to worry about it any further. And again, it's adaptable, and that's important to you guys because there's pretty much a workaround for just about any scenario that you could come into. We've seen a lot of things and helped a lot of installers and contractors with, you know, adapting the design to be able to suit the job that they have in front of them. So that's important. You know, you're always welcome to call us or text us, email us with questions or pictures. We're happy to help out with that type of stuff. So some of your upselling opportunities with the carbon fiber would be some of those other products that we just briefly discussed. There are situations where installers are teaming up with new home builders to use the carbon fiber as a preventative maintenance measure. Basically, they do the installation at the time of the home being built to keep any damage from occurring, and then therefore the home builder gets to increase their warranty on that structure. So it gives them a competitive edge against other builders in the area. So that's something that you guys can kind of kick around and see if that would be something that would work out for you. So yes, we've already talked about working with other types of reinforcement repairs, and then the window openings and egress windows. Again, Tough Wipe's great. They're not expensive. You know, I had a crew that was the middle of winter. They were heating up their epoxy in the truck up on the defrost. The guy grabbed it, didn't realize it was going to be that hot, tossed it out of his hand, hit the concrete pad, and exploded on the front door or the garage door of the homeowner's house. Fortunately, he had some Tough Wipes on it. He cleaned it up, and the door was cleaner than the one next to it. So, you know, they're worth their weight in gold. We've had guys that have gotten epoxy out of their hair with them. You know, if nothing else, just not having to manually pull epoxy out of your arm hair is worth the $20 they cost. Last thing we always talk about, guys, is our marketing support that we offer. It's something that we want every one of our customers to utilize. So we have a pretty big offering as far as what we can help you with. We have animated presentations. We have PowerPoints and slideshows that you can use at the time of your inspections and sales calls. We have sheets that you can print off and take with you to those appointments and leave behind. We do a ton of case studies with our contractors, and that's something that we really like to be part of. That makes us a stronger company and you guys a stronger company. So if you guys do a cool project or just a normal installation, it doesn't matter. You know, send us some information and some pictures of it. You know, put it on your Facebook or LinkedIn or Instagram, and you know, tag us in it, and we'll reshare it. We'll discuss it. You know, that case studies are very important to all of our customers. That's how they get jobs. That's how we get jobs. You know, that's what leads to engineers contacting us, which ultimately gets fed down to our installers. So they present a ton of opportunities. We have pull-up banners for trade shows. So if you guys do any home shows, we have materials that we can provide for you guys at no charge, so you can take that with you to help you know, educate some customers in your area. We obviously do a lot of videos on our social media and our YouTube page. So all of our, we have a lot of CGI videos that kind of help explain some of the different applications to people that wouldn't necessarily be from the industry. So they're pretty useful tools as far as helping develop just kind of the education background on a lot of the products. And then we have some pretty cool ones that are just, you know, kind of the shock and awe, you know, of us doing fun things at the shop. We call them the hillbilly test. You know, like setting a truck on some concrete blocks that have carbon fiber on it. Just the cool stuff that kind of shows off how strong the carbon fiber is. We recently redid our website. So all of the technical data is available front and center. So if you go on our website, which is rhinocarbonfiber.com, and you look at the bowed wall section, if you scroll down through there, you'll see a TDS, an SDS, and you'll see engineering documents are all associated with that repair now. So they're all readily available if you have an engineer or a building inspector that needs something or wants to see something. It's as simple as just hopping on our website. It's right there. It's in a PDF. You can download it, print it off, do whatever you need to do with it. And then finally, we do a lot of apparels and giveaways. So, you know, if you guys want shirts or hats or something like that, let us know. We'll be happy to provide that to you. And then if you guys need any assistance with your website as far as content or advertising that you're a Rhino installer, we have all of that stuff pre-generated, and it's just stuff that we can email off to you. That way you don't have to do the legwork to accomplish any of those things.